Hey everyone, today I want to show you some socket programming in Ruby. Ruby has some really great wrappers around the hard stuff in sockets to make it super simple. Here I have like a really simple 3-line program. What it's doing is saying TCP server loop, so it's going to start TCP server on port 3030 as I specify here, and for each client that it gets, it pushes the client into this block, and here it reads what it can from the client and writes it right back. This is basically just an echo service. So I want to tear this apart and show you all the stuff it's doing under the hood for you. But before we do that, let's go ahead and just test it. So I'm just echoing foo and piping that into netcat on port 3030 where this program is listening, and you can see I get foo back. And not only that, just by virtue of using that wrapper that Ruby offers, I also get IPv6 support. So I've got this one really short program that's listening on port 3030, IPv4, IPv6. So in this screencast, I want to break down just this method, TCP server loop, and all the things it's doing for us. These things, write and read, are pretty common on any Ruby I/O object, and I won't dig into those today. So let's So here I've got the same file, but I'm going to start breaking it apart. So what does TCP server loop do internally? It actually depends on two methods, both of them on the socket class. One is TCP server sockets. This one returns a pair of sockets, one IPv4 socket, one IPv6 socket, both bound to port 3030. And the other method that it uses on socket is accept loop. Accept loop, you pass it a list of sockets, and so for each of the sockets in this list, if any of them get a connection, it takes that connection, pushes it into this block. So this accept loop is interesting because we could pass it potentially a huge list of sockets and have it listen on all of them, and if any of them get a connection, treat them the same way inside this block. Now, the first example I showed you and this one, there's nothing happening in parallel. Simply taking this list of sockets and sequentially handling connections as they happen. So it started out as just one method call, and there's these two underlying method calls. So what are these methods doing? Let's start by breaking down accept loop a bit. We'll write our own accept loop. So accept loop takes a list of sockets, and what's it going to do with those? Well, if this was just a single socket, it'd be pretty simple. We would just say, a new client comes in when we're able to accept a connection on the socket. This is a blocking call that will block until a new connection arrives on the socket. Accept loop also takes a block, and assuming that we only had one socket, it'd be as simple as wait for a connection and then call the block. Of course, this would be inside of a loop. But it's not quite that simple because we've got a list of sockets, right? And since this is a blocking call, we're not going to be able to just block on one socket while the other sockets may be piling up connections for us. So what we can use is select. Now select is kind of a Swiss Army knife of stuff you can do, but very generally it allows you to monitor I/O objects for state changes. So by passing in this list of sockets to IO select as the first argument, we're asking it to return us which of those are readable. So what select is going to do is it's going to block, and let's say we pass in a list of 5 or 10 sockets. If it's at a certain point in time, 1 or 2 of those sockets become readable, as in they have data available, or let's say connections available that we could accept without blocking, it's going to return those in this variable here. So we can use that to basically reuse this piece of code here. So in a loop, we're going to select on our list of sockets. When any of them are readable, we know that means there's a connection waiting on them. Since they're server sockets, they're not going to have data we can read, but they might have connections we can accept. So in the readable, we'll accept the connection and push it into the block. Now if I call our accept loop instead of the socket accept loop, theoretically everything should still work. We get an error, undefined method read for, yes, the issue being here, accept isn't actually returning just a client, it's returning an array of client and the attr_info object, an object representing the address of that client. But since we're not going to need that here, we can just assign it to nothing and try that again. Cool, now we can see that it's still working on IPv6 and v4. So that takes care of accept loop, and that's basically as low as we can go with it. IOSelect is a system call. We're delegating to the kernel at this point, asking it to monitor these sockets for us. And same with accept, it's a system call, asking the kernel to give us the next connection, and then we call the block. But this one, we still haven't discovered what this one does. And again, we can get there by running our own implementation of it. So we know it takes a port, and then it's pretty simple to create an IPv4 socket. All we have to do is use this constructor, or we're going to be making a server in this case, and it just needs a port. That's simple. IPv6 is a bit trickier because there's no fancy constructor like that for it. We have to use the lower level methods. So we'll create a new socket, inet6, specify that it's IPv6, and this will be a stream socket, specify that it's a TCP socket. Then we need to bind that socket to an address. And what address are we going to bind to? Let's go with info TCP. I believe it's port and then host, and we're going to use the this is the IPv6 equivalent of 0.0.0.0 to allow connections from any host. So then we need to take our socket and bind to that address, and then tell our socket that it should listen for connections. So a couple of details here. So whether our socket is a listener or whether it's going to be connecting as a client, it needs to bind to an address. But it's this step where we tell it to listen that tells the kernel this is going to be a listener socket as opposed to something that's going to connect to another host. And the argument we pass here is actually an integer, and it represents the size of the listen queue we want to have. So if our program is busy inside the block handling a connection, and we have new connections coming in and piling up, they're going to be queued up, and this is this number here is the size that we're willing to tolerate of pending connections, after which they'll be rejected. So this constant represents the largest size we're allowed to use. So now we've got an IPv4 socket, an IPv6 socket. We can return those. And we can stop using the one on socket. Put that here. And theoretically, we should be working again. TCP node name nor service not provided, line 8. So it didn't like this. I think I got these backwards. Let's see. Seems to be happy now. Now I'm working on IPv4 and an IPv6, so we're still working. That's awesome. And one more thing we can do to get the lowest level I can take you, at least in Ruby, is just to break this down to look more like this. IPv4 socket is very similar. The main difference actually is rather than specifying the protocol family as inet6, which is IPv6, we use inet, IPv4, and then this part we can more or less copy. And instead of binding to the wildcard IPv6 address, we'll use 0.0.0.0, and obviously change these names. And that should get us back to working. Yeah, perfect. And so this process here of creating a socket, binding to an address, and putting it in the listen mode is something that's obviously not specific to Ruby. This is how the socket programming API is used. So whether you're writing socket programming code in C or in Python or any language, at the lowest level, it's going to look much like this. And then in a language like Ruby, you've got wrappers on top of that, and layers of wrapping so that you don't ever have to think about things at this level. So to wrap up, we started out with something very simple, this 3-line program, which is wrapping a ton of functionality for us and really making this look so simple. And really what it's wrapping is all this, and if you look inside the file that implements those 2 methods we looked at, the TCP server sockets and accept loop in Ruby core, it's longer than this. It's a little bit more defensive, but it does at least this much. Alright, that's all I have for today. I'll talk to you next week.